In this video, we're going to go from augmented matrix to determining what the solution is. Spoiler alert, these are your special cases when you have no solution or infinitely many solutions. So it says the reduced row echelon form of a system of linear equations is given. Write the system of equations corresponding to the given matrix. Use X, Y, and Z as variables. Determine whether the system is consistent or inconsistent. If it is consistent, give a solution. Your consistent systems are your one solution and your infinitely many solutions. Your inconsistent is no solution. So if it is no solution, then we're done. But if it has one solution or infinitely many, then we must give the solution. So the first thing we're going to do is write the system of equations corresponding to the given matrix. So here, equation 1, remember this is my X, my Y, and my Z column. So this one tells me 1X plus 0Y plus 0Z equals 1. So this is just X equals 1. Equation 2, I have 0x plus 1y plus 0z. So that's just y. The bar is my equals and it equals 2. And then lastly, we have 0x, y, or z. So I have 0 over here. And 0 is going to equal 3. When you have a no solution or an infinitely many, you're going to have that bottom row right there being all zeros. So now it comes to, does this last equation make sense? And if it doesn't, in this case it doesn't, because this is a false statement, this is your no solution. Or they might list it as inconsistent. Okay, so on B, we're going to start by doing the exact same thing. My equation 1. We have 1x plus 0y plus 2z equals 4. So that is x plus 2z equals 4. Equation 2 is 0x plus 1y plus 3z equals 5. So that is y plus 3z equals 5. And then equation 3, we have 0x, y, or z, but it equals 0 because I have no variables here, but this is true. This is my infinitely many solutions. Infinitely many is consistent. So if it is consistent, we must give a solution. So what this last line right here is telling me is that Z can equal any number. So now I have to come up with something for X and Y. The only equation that has an X is equation 1 here. And how could I solve this for X? Well, I could solve this for X by subtracting over my 2Z's. So X equals 4 minus 2z. I'm subtracting 2z over. Now I need something for y, and the only equation that has y is my equation 2. We're going to do something very similar. When I solve for y, I can do that by subtracting 3z over. So y equals 5 minus 3z. You can also write this as negative 3z plus 5, and you can rewrite this one as negative 2z plus 4. That doesn't matter. Once we have something for x, y, and z, we can write that as an ordered pair. Which is always x comma z, or x comma y comma z. So my x is 4 minus 2z. My y is 5 minus 3z. And my z is any number, which is z. So now, of all those infinitely many solutions, if I want to pick z to be 1, I can plug in z here and get my x coordinate, and I can plug in z here to get my y coordinate. This gives me a formula to find any of those infinitely many solutions as I want.